Imagine capturing a snapshot of the universe just 380,000 years after the Big Bang. An image so faint and ancient, it's been journeying toward us for over 13 billion years. That's what scientists have just achieved with new data from the South Pole Telescope. In this video, we're diving into why this discovery is so monumental, how it was made, and what it could mean for the way we understand dark energy and the universe's expansion. At the coldest place on Earth, in the heart of Antarctica, stands a telescope that might just be changing everything we know about the cosmos. The South Pole Telescope, built specifically to measure the faintest light in the universe, has now produced results that rival even space-based missions like Planck. The reason this telescope is so special lies in its location and its latest upgrade. The dry, stable air at the South Pole creates ideal viewing conditions, free from the atmospheric distortions that plague many other ground observatories. But it's not just about location. The recent upgrade to the SPT-3G camera gave the instrument a 10-fold increase in detectors compared to previous versions. That means more light captured, more sky covered, and more detail revealed. This isn't just a technical improvement, it's a shift in power. For decades, space-based observatories like the Plancksatellite set the gold standard in cosmic microwave background, or CMB, observations. But now, with its 2019 to 2020 dataset covering 1/25th of the sky in unprecedented detail, the South Pole Telescope is matching, and in some cases surpassing, those benchmarks. What makes this even more exciting is the potential scalability. Unlike space telescopes, if something breaks on the South Pole Telescope, scientists can walk up to it and fix it. No rocket launches, no orbit maintenance. That practical advantage is helping shift the focus of cosmology back to Earth. One of the most fascinating parts of this new data is how it's throwing more weight behind one of cosmology's biggest mysteries, the Hubble tension. This is the ongoing conflict between two different measurements of how fast the universe is expanding, one based on observations of nearby galaxies, and another based on CMB data from the early universe. With this latest release, the South Pole Telescope has confirmed this tension with remarkably high statistical significance. This isn't just an echo of what previous studies have found, it's an independent verification using entirely different instruments and methods. That's a big deal in science. When multiple, unrelated datasets point to the same anomaly, you can't just brush it off as noise, but that's not the only curveball the SPT has thrown at us. There's a growing discrepancy between what the CMB tells us and what galaxy surveys like those from the Dark-Energy Spectroscopic Instrument, or DESI, are showing. According to our current model of the universe, Lambda CDM, these numbers should align, but they don't. And the new SPT data sharpens this discrepancy even further. These findings suggest that our current cosmological model, while incredibly useful, might not tell the whole story. Something is off. Whether it's unknown physics, a misunderstanding of dark energy, or a hint at new particles, we don't know yet. But that's what makes this so thrilling. So where do we go from here? This isn't just about patching holes in our current theories, it could actually be the beginning of a completely new paradigm. And the South Pole Telescope is leading that charge. As more data from the SPT-3G instrument becomes available, scientists will be able to test a wider range of hypotheses with even greater precision. If there really is a departure from the standard model, the rest of the SPT data will help magnify it. And if it turns out to be noise, well then we've still managed to produce the most detailed ground-based CMB map in history, and that alone is a huge achievement. But this also speaks to a bigger trend, the resurgence of ground-based cosmology. With advances in detectors, software, and global collaboration, telescopes on Earth are no longer playing second fiddle to space-based observatories. Instruments like the Atacama Cosmology Telescope in Chile and future projects like CMBS-4 are poised to expand our vision even further. This democratization of cosmic research means more scientists, more data, and more opportunities to cross-check results across different platforms. The more independent confirmations we get, the more robust our understanding becomes. This isn't just a win for the South Pole Telescope. It's a turning point for cosmology. With only a fraction of its new data analyzed, we're already seeing confirmation of long-standing tensions and hints at deeper anomalies. These results may force scientists to rewrite key aspects of our cosmological model, opening doors to new physics and unexplored territory. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching and see you next time.